fairly sure where this gets stored, whose Google Drive.
I think Talat is maybe the owner, so it gets stored.
Yes, Talat has it, and it should attach the notes directly to the meeting after this is done. So.
Okay. Okay. Since I'm talking, I will go first, and then just read down the list of names as I see them on the attendees. So I'm Micah Kornfield. I work at Databricks. One thing I wanted to bring up is there's any more discussion on what to do about it in 96, or if we feel comfortable changing the sort order to be more specified there. Adam, I think you're next on my list.
Cool. Hi, I'm Adam. I work for G Research. Currently working a bit on Parquet modular encryption support in the Rust ecosystem, but don't have any agenda items. Just really want to listen in today.
Okay, Ditya.
Hello, hi, I'm Aditya. I'm part of the CMU DB variants team. I'm here with Martin. I'm just here to listen.
Yeah. Aihua, am I saying that correctly?
Yes. My name is Aihua. I'm working for Snowflake. I'm more interested in variant update. Thanks.
Okay. Alex.
Hey, I'm Alex. I work for Google. I'm just generally kind of new to this space, so looking to listen. If anybody has any tasks I can take on, like code is the best way to learn.
Well, I have some suggestions, but yeah, take that offline. Giz, I'm sorry, I'm butchering your name, I think.
Yeah, so I'm Gijs. I work at Polars. I maintain the Parquet reader there, and I'm also just listening in.
Yeah. I have Adam twice. Oh, sorry, Daniel, I skipped you.
Yeah, my name's Dan, and I'm with Databricks, and I'm kind of here to catch up and see if anybody's going to talk about interval type. That's probably the most interesting thing to me at the moment. So.
Okay. Jeff.
Hey, I'm Jeff. I work at Snowflake. I don't have anything particular for the agenda today.
Martin.
Sure. Martin Prammer, Carnegie Mellon University variant team. As always, happy to talk about variants, but we don't have any major updates. Few pull requests have gotten merged, but nothing major to talk about from our side.
Prateek.
Hi, everyone. This is Prateek, part of the Snowflake team. Mostly here to listen for today.
Okay. Raul.
Hi, I'm Raul. I work at QuantStack, mainly on Apache Arrow and the Parquet CPP implementation and PyArrow, Parquet, etc. So I'm just listening in and seeing what people is interested on. I'm kind of interested on the new footer, but yeah, nothing to say much about it.
Okay. Rock.
Hey, I'm Adam's colleague, also working on modular encryption. Not really, I don't really have anything for today, but I am curious about white schema, metadata stuff. So what Raul just mentioned, basically.
Okay. And then Ryan.
Hey, I'm Brian Blue. I work at Databricks. I am interested in variant and primarily like what the next steps are. We've got the read and write implementation in Parquet Java. It would be great to get that out in a release so that we can start using the labels and then producing those data files that I think we would want to test with. In fact, a colleague here who unfortunately was not able to make this meeting at Databricks has generated a bunch of those files. So if anyone knows the test framework that we're aiming for, basically how do we want to, how do we want to use those files and put them into what the Parquet cross-format test repo? What is that? So love to hear more about that.
Yeah, we can. Why don't we finish going through people and then we can talk about that under variant stuff. Yan.
Me, Yun.
Sorry, I'm skipping. I copied about a bunch of people's names before the meeting started, and then
I'm just making sure you're calling me. Hi, my name is Yun. I work at Snowflake with Aihua, and today I'm mainly here just trying to see if we can conclude on the interval type email thread so we can have a move on path to move forward.
Okay, great. Sandeep.
Hi, I'm Sandeep. I work at Snowflake. I'm just here to listen today. Nothing on the agenda.
Okay, and then Brian.
I wasn't sure if you'd get me, so I messed things up with my meeting room. I'm Brian Hewlett from Google. Nothing to add to the agenda today.
Okay. Okay, cool. Let's get started. So, hopefully N96 is maybe short, or I was asked to bring this up because people working on it are in a time zone that's not super convenient to meet. I think we've answered most of the questions, and the last thing, primarily when Spark will switch. There's a little more complication. We know when Delta will switch, which is I think primarily what's written today with Spark and Parquet, at least from the Databricks side, but open source Spark just switching the default is another question which we're trying to get an answer to. But I don't think there's any objections in principle to changing the sort order to be well defined for N96. If anybody has opinions here, obviously we'll follow up on the mailing list.
I'm good with that, and in fact, I think I prefer explicitly defining and writing a sort order, just so that we know that the client did intend to produce timestamp stats.
So a new sort order is what you want, and not just
Wait, are you just saying that the implicit sort order of Int96?
Yeah.
I think that, so in my opinion, we need to do a lot more research in order to verify that before we introduce the sort orders that we are currently looking at. We did not produce any Int96 stats. Because if I remember correctly, 7 years ago, we were producing garbage Int96 stats from Parquet MR.
Yeah. I mean, so I still feel that's we can safeguard that fairly easily with an implementation note, because most things don't produce it today, but I
don't know. I never like to depend on a particular writer version to gate a feature. I mean, it seems like we should either explicitly say this uses the timestamp sort order for Int96, or we should verify that we never produced Int96 stats at all. I really do think that we produced Int96 stats, but if we can, show that we never did, then it's okay.
Okay.
I just don't want to have a situation where tables with 8-year-old files are all of a sudden being matched, and we have correctness issues. I guess you would not, it wouldn't really be a correctness issue, but you would have overscanning of really old data that's potentially in Glacier or some storage tier you don't want to touch.
I mean, I think you could eliminate data, so I think you would have correctness issues, right? I haven't thought about the exact comparison.
Well, you're going to have false positives for data files if you have incorrect stats. And then when you do the actual row-based calculations, we do know that all the row-based values are correct int96 timestamp values.
Right, but I think you can have false negatives also, can't you? Say like, I know I don't.
Oh, yes, you're right. You can have false negatives.
So yeah, so like I think it's either depending on version guarding if we find we've written it, or like if we're okay saying if Parquet Java has never written it, then like we don't need to sort order.
I mean, version guarding seems very brittle to me. Like you have to parse Parquet MR versions and know which one. Like if we're doing this, let's just do it right.
Okay. So generally, even if you never produced it, you want the sort order. That's what it sounds like.
If we're confident we never produced it, then I think it's fine to introduce a sort order. But that's assuming that we've never written a Parquet file with a min or max for those bounds.
Yeah, I think Rust has been potentially writing them. I forget the exact stats. Certainly the code was there, so we can follow up.
That's true. And I guess that comes back to like if we're using if we have to parse those strings, because Parquet that goes back to the user writer version string to detect Parquet Rust versus Parquet MR.
Yeah, so it sounds like you're more in favor of trying to add a sort order.
I would certainly prefer that. I don't know if anyone else agrees or disagrees, but you know, it doesn't seem like that heavy of a lift for us to, you know, correctly annotate what we're doing.
Yeah, I mean, I think the one pushback there by that, you know, the ecosystem like potentially loses out. Like in Databricks, we can like, you know, whitelist things produced by Photon to know that they were correct anyways, but it means that like other people in the ecosystem can't necessarily like read those stats on any file.
The rest of the ecosystem could say that if it's produced by Parquet, like it's up to the clients to make that inference.
Yeah, that's right. Okay. Variant update. Sorry, I know this favors people who are first alphabetically, so maybe we can find a way of randomizing agenda items later if we run out of time.
I can start. So Ryan, you specifically mentioned that you've got Parquet files with variant data in them, if I'm understanding right.
Yeah, so what we did based on, you know, so we got the write path in to Parquet Java, specifically the Avro write path. This has a couple different ways of writing. First of all, you can pass the shredded values into, you can pass shredded Avro representations in, and it'll write them to a shredded schema as long as it matches exactly. And you can also take a unshredded variant value, pass that in, and it will correctly shred it according to the schema. Then we have test cases for both reads and writes. So the read test cases are based on passing the shredded Avro records in. And so we have this representation of exactly what your data should look like if you were to read it as structs and records. We use that to write the data, and then we interpret the variant value the encoded variant value coming back out. And so we can produce those things, right? We can say, for your reader, here is a shredded variant and the variant you should get when you interpret it. Interpret that shredded structure. And we have that for all of the test cases that are shared between Iceberg and Parquet Java.
Okay.
So that covers the read side. The write side, what we do is we actually have just a list of variants, and I'm not sure how we want to put this sort of thing in the test harness, but we have a list of variants, and we have code that, you know, shreds the variant into every other variant's shredding type, And if it fits, then we use it. If it doesn't, then you do the fallback, and we sort of have a number of cases for trying to put values in a different shredding schema and verifying that you get the same value back out that you put in, regardless of whether parts of it were shredded. That I don't think is very portable, other than just to share the test cases and the test harness that is, write this value unshredded and read it back, write this value completely shredded and read it back, and write all of the values to one of the shredding schemas and read them all back and verify them. At least for the read tests, I think what we would do is essentially we need some place to have a file and the variant that we expect to come out of that file.
Okay. Just put an issue in chat. This is specifically in the Parquet testing repo. Andrew started this up however long ago, and this was the start of requesting any files that are format accepted variants, just anything that, even if it isn't something that we're saying, okay, this is going to be canonical, we are 100% agreed on the spec, we are super solidified on this, just anything that we can use to start testing all the different variant repos. Andrew's going to have an absolute field day once he sees that stuff. So they call it an early birthday present or so. He'd love it.
So what format do we need to produce for this, though? Because we can't really have, I mean, we could have like a Avro file paired with a binary file of bytes that represent a single variant value. Is that what we want to do?
Probably fine.
So I think what Andrew checked in was kind of JSON representations for each of the things, and JSON isn't. Yeah, I know JSON isn't like there, but I think I think it's probably.
Well, we need all of it, is the thing. We'd like to have JSON that we know can go to variant correctly. We'd like to make sure that we have the memory format correct as well. We'd like to make sure the binary, it's being interpreted correctly. Like, everything here is useful in some way.
There isn't a specification for, like, we removed the spec from the spec, the part about how you interpret a variant as JSON.
So I don't think we need like programmatic JSON. I think so Avro has a serialized text form, right? Or like a serialized JSON form. Like I would say, like the serialized like JSON serialized Avro gives you a good description of it. Then the binary equivalent binary variant, and then the Parquet file associated with it, that gives you text description. That it's not so important that's an Avro, but at least it gives you.
That's doable if we can produce whatever format we want. All that's going to be is like a JSON field that is like, hey, this is a variant. Here's the metadata and here's the text, and then that's going to be whatever encoding they use. I forget. It's not base 64. It's not base 96. It's something else to dump everything as JSON strings.
Sorry, I think I was imagining something different. I think at a high level, I think you need three things for testing. You need the high level. You need textual description so people can understand what the contents are, and you need the actual variant binary stuff. I think Andrew just created his own format, his own binary format, if I remember correctly, in the Parquet testing. But we can go back and look what's there, and then we need actual Parquet files.
I think what I'll do is I'll connect. I'll pass on this issue to the guys that are working on this at Databricks, and then they can go back and forth with Andrew on what sort of binary format he wants for the expected values. Because we've got the files. They're each a file of a single record that has an ID and a variant column. That variant column should produce, some expected binary variant. Although we also need to, there's a small caveat here, which is that there are multiple representations of variant that are valid for interpreting these things, because you can use short strings or you can use so we need to have some agreement on variant equality, which we generally, I think, have in our test harnesses. So you can look at that.
Yeah. So it sounds like, Ryan, you'll follow up. And
I'll follow up with our team so that they can work with you guys on that issue.
If I remember, actually, wait, Ryan, weren't you working closely with Matt Topol, I think, for the variant implementation with Go?
So I talked to him about what the representation in Arrow would be, but I have not followed up on.
Yeah, actually, I worked with him. Yeah.
Oh, okay, perfect. I remember he mentioned Ryan's name. Good to hear that.
Yeah, that's yeah, actually, that's
Okay,
yeah, he from Snowflake side. But unfortunately, he didn't have time to work on shredding side, so he finished basic encoding. Yeah.
So what he was able to get done was the ability to shred, not any of the controls determining and applying shreds like when you would want it, any of the shredding strategies, etc. Just the lever of shred this. And from our perspective, but that being said, from our perspective, the Matt's code base is really clean to look at, and it's also just this monolithic file that we can deal with. And there's that. There's everything we can compare with the Java, because Rust, we're about to get started. I think a few people have chimed in and said they want to start actively working on variant shredding. But outside of that, I don't think we've got any significant progress on shredding at this point. So making sure that it's like these are the examples that we're going to base it off of, I think that's ready to go. Outside drop.
Yeah, I mean, we certainly now have all of the test cases that we used for the Java side of things, and so we'll make sure that those are captured and committed somewhere. I don't know what we want the test harness to be like. It would be cool if we had like an easy one in Go. If Matt has time to like do the implementation to verify his own Go code, that would be awesome, because then we could just use that as a way to test Go, and then also create that test harness for the C++ and Rust side.
So I think once the shredding is dealt with in Rust, like, is there anything else much more to touch on? Like, that's one of the well, okay, there's some outstanding issues with Rust as well. I think one of the things they'll need to get hit is the extension type round tripping for the Rust library. There might be a few other bookkeeping issues, but as far as I'm aware, this will be, once there's shredding in Rust, that'll be like, we're getting really close to having variant in everywhere we want it, I would assume.
Yeah, I mean, we also should go and check on the work that Matt has done, because that might be our second implementation. That means that we can actually finalize the spec. So I'll touch base with him. But yeah, we're getting close, I think.
Ryan, I think you mentioned the release. Given like we already have kind of the ability to generate test data, like I'm not clear if that's urgent or like is blocking anything.
Well, we certainly need it in the Iceberg community to create data files that actually label the variant data that they're storing. So I would love to get that done.
Okay.
I don't know if anyone else needs a Parquet Java release or if there are any plans to do it, but I would love to, get that out. And I don't think that we want to block that for any reason. I mean, are there concerns about releasing the code with Avro support for variant?
I mean, I think the main thing is just like it continues to make the spec murky until we have the second implementation, right? Like now that like Iceberg is writing them.
I guess my question is, are we going to block the Java implementation from being released until we have the variant spec finalized?
No, I don't think we should do that. It just I think we just need to advertise it very well and like make sure that people still understand that it's like experimental, in my opinion. But
well, and maybe it won't be experimental by that time because we have a Go implementation.
Yeah, so we need a volunteer for the Java release. I think is the main.
Yeah, I can do that because since we also need that.
Thanks.
Yeah, I think there's some. I forget the exact Apache requirements for who can run the release. At the very least, I think you'll need to get registered into get your keys registered, but I don't know if it needs to be a commitment.
Yeah, I can check with you offline.
Yeah.
It actually depends on the project. Anyone can do, I believe, the tarball portion of it, but I think that the Parquet release process, at least the last time I did it, did not build the convenience binaries in 2 stages like we do in other projects. We build the release tarball and the binaries. Actually, you should be able to build the release tarball. You'll need someone to release the binaries and do the Maven release process.
But still needs to be signed either way, though, right? Like, and that needs to be the key needs.
Oh yeah, but it's easy to add a GPG key to the keys file.
Okay. Okay. Interval type.
Yeah. So for interval type, I think we had a lot of discussion on the thread also. Based as a brief summary, I think we can also summarize at the end. Like it seems like we do want to introduce 2 types at this moment. One is the year-month interval, and the other one is update to nano duration to make it very clear it's a duration, not a calendar time. And then in terms of length, for the nano duration, we probably want to start with int 64. And then I think there's another discussion that's going on with to introduce in the 128 versus just a fixed length byte array 16. So while the other discussion wants so fixed on the other discussion, we can potentially in the future extend the nano duration to have a higher range representation. So I guess like if there's no other if we are all good on this kind of summary, what we can do is we can progress on introduce these 2 new interval type in the Parquet, and meanwhile we can also have the discussion about the 128 versus the fixed byte array. If that sounds a good plan to everybody.
Yeah, that sounds fine to me. I mean, the official thing, the official decision is on the mailing list. So like we need to. If we, hopefully by end of the week, if nobody chimes in, like we can consider it finalized and try to get the actual code and implementation done. It seems like, yeah, the 128 seems like it's going to be a somewhat longer discussion, and will also make things a lot more complicated.
Okay.
But yeah, hopefully nobody objects to the current plan. I'm happy with it, as is.
I think that sounds good to me. I just have one question about year-month interval versus duration nanos for the day, or sorry, hour second, day second,
daytime.
Daytime interval.
Yes.
Okay. Daytime. Okay. Should we use interval terminology here for both interval types? I'm not familiar enough with the subtleties of this to know whether, like, if we call it a duration in nanos, is there going to be confusion from people that don't understand that this type should have some sort of SQL semantic? I think it should be okay, but I just want to like raise the question.
I think that mapping is like up to people, like up to engines, right? Saying that like for our engine we use duration nanos as this type, right? Like what was kind of established on the list is at least ANSI SQL. It's effectively a duration because days are always A6400, but there's other engines like Postgres that consider days to actually be the calendar type so that they aren't always 24 hours. And that's kind of where
so the fact that we're just saying, okay, I'm good with that. Thank you.
So there's some other subtleties which I assume like maybe it's defined engine and gloss over like leap seconds and things like that. But
yeah, there are those issues, and then there are also the like, yeah, the issues of how to layer the interval types on top of this with casting and sort of engine semantics, but those should not affect Parquet.
Yeah, and like it leaves the door open if like we actually want to have an interval type that's a calendar type, that corresponds with arrows thing. Somebody can try to drive that through. Dan, I think you had you were particularly interested in this. Did you have any thoughts here?
I didn't have thoughts on it. I was just following on the thread because there was a lot of activity there. And I was just kind of catching up. So thank you.
Okay.
I actually had one other question because the discussion around the int 128, if we're introducing that, I think that was also brought up in the discussion around like nanosecond timestamp precision previously, and we kind of deferred that for a 64-bit implementation with a reduced range. Is that something that we would want to open up then?
Yeah, I mean, I think all these types will eventually want to be expanded, right? Like, so there's nanoseconds, picoseconds that have been mentioned in passing. So like we want something to represent a wider range ultimately for like SQL semantics and like to like not undeprecate int 96. But I don't know. The one place I can see it blocking is I think this is the first time when we've had something that we're defining as narrow type, and in the future we might want to like increase the range. So we need to be a little bit careful with like the APIs that we potentially expose.
Yeah, I guess my concern is just that like if 128 is a broader topic and we have a dependency on solving that here, or if there are concerns about introducing it narrowly for this and then later, addressing other use cases, are we okay with that?
We're specifically not doing int 128 for interval. Like we're keeping the int 64 range as like a way to bypass that debate.
Okay.
Does that?
We could also use int 96.
Yeah, that's formally deprecated. So I don't know if that's a good idea.
Yeah, and I think with int 96 is it's not actually, it doesn't match any interpretation of like integer.
It's the width we want.
Yeah,
I'm kidding. Okay.
Pico? Don't we need more Pico? So
I thought you were kidding, but I wasn't quite sure. Okay. New footer. So I think Alkis is not here. I don't know the exact progress here. I don't know if anybody else from Databricks has been in touch with him. I think if there's other people, like I know his bandwidth is, if there's other people that are actively like looking to push this forward more quickly, maybe we can do some sort of handoff there. But I don't know if anybody else had other things they want to talk about new footer.
Yeah, we're quite. Oh, sorry.
Go ahead, Adam. Yeah.
I was just going to say we're interested in this from G Research, but we haven't done any work on it. But if there is somewhere we can help, then yeah, we would be keen to talk to Alkis and yeah, start contributing.
Adrian.
Hi, folks. So I've just been listening along. I work at, I've never been on these calls before, so I'll introduce myself. I work at Pydantic. We're big contributors to Data Fusion. We have done a lot of work with metadatas and footers and stuff like that. It's for reasons that are beyond this call. We have files with a lot of columns, and so metadata becomes bottlenecks and stuff like that. And the one thing I wanted to flag that I opened the discussion about the new footer approaches was that in our experience, I/O ends up mattering just as much, or if not more, than like parsing speed. Because I think there was like some benchmarks that showed it was like much faster to parse, but it was twice the size. And in our experiences in practice, when you're reading from object storage and things like that, how much data you're downloading, it can end up being the bottleneck. That's one thing. And then the other thing that we found is a huge bottleneck in the current footer approach in regards specifically to stats, is that there's no ability to select subsets of the data. At least the Rust implementation currently has to download the entire thing and parse the entire thing. We've talked about making it possible to only parse subsections of it, but as far as I know, there's no ability to say, hey, I'm only going to read these 3 columns. And because I did previous pruning or something, I know I'm only going to read this one row group. Only get me the stats for these 3 columns for this one row group. So those are things I wanted to flag as just like general thoughts on any sort of new footer type. It would be very nice if it could do that sort of thing. And then I wanted to suggest kind of a something a bit wild, because we recently switched from another system to just storing the stats in Parquet files. And that has all those advantages, obviously, because you can select only, some columns, you can select only some, row groups and stuff. So like, would it be the craziest idea to store like the, stats and stuff that we have in footers as, Parquet data-ish, like kind of like call it nested Parquet or something? One of the big advantages we found with this is that because the system already knows how to process Parquet and do things like use stats to prune, the Parquet stats files now have their own stats. And so you end up like doing like mins of mins, and like it actually works.
Yeah, so I think there's like 2 things. I'm not sure what you're suggesting. So like having stats external to Parquet files, storing Parquet files, kind of looks like a table format. So, and this is kind of where Iceberg.
Exactly.
Yeah, so that's not crazy. So like, maybe not right. Like I think the other thing you maybe say is like embedding a Parquet, like essentially the footer becomes a Parquet file.
Right. That's basically what I'm saying. I'm saying like, oh, these other systems, including us, store it as external Parquet files. That seems to work pretty well for many reasons. Would it be crazy to just take those bytes and put them in the footer of another Parquet file?
I don't think it's completely crazy. I think like it'd be nice to have like a POC and compare that to like the flat buffer approach, right? Like so. Yeah, like I think that's I haven't had time to pursue this, but that was like more aligned with how I was thinking about it, because I think there's challenges there, but it might be interesting. Yep, Prateek.
What I was trying to mention is stats. Definitely, I think you're right on. It ends up being like bloating the footer, and I think in Alkis's doc or in one of his PRs as a proof of concept, he did mention, I think 30 to 35% of the bloat and the parsing time comes from the stat. And that's where I think the recommendation over there was moving away from like string or serialized representation to having specific integer values to represent the min and max values. And that significantly improved the parsing speed. With that, I think the first thing that you pointed out, like the POC suggested flat buffer as an alternative to the serialization. And that, I think even the numbers, empirical numbers that were posted in the doc did show for some cases like a 50% increase in size of the footer. So if we are storing, like if one has to parse the entire footer, and you're parsing it in its entirety, like that bloat a few megabytes for all the files for the parallelism that one like analytical engine tries to achieve, will that end up being a detriment towards this specific approach? Are there better serialization techniques which continue to have faster speeds and random lookups, like just initializing the columns that are needed?
Yeah, I think yeah, like I said, I think we need to like prototype some of these things to see what the trade-offs are. I think certainly this is why I think like embedded Parquet is kind of interesting, right? Because if we add new encodings, we get the benefits of those encodings as well for some of these things, or something like embedded Parquet, right?
And
so you do
you already have the code.
Right, and you already have the code, so that's why. But I can't answer, like, I don't think anybody knows off the top of their head the better. Like, I think we all have suspicions on like what might work out, but I think the best way of doing this is trying to do some more empirical measurements by trying to implement it. And like, ultimately, we need to decide on one. But there is a big design space here that should probably be considered, not just say flat buffer solves it all. Like, I think the thing with flat buffers is it's still row oriented, and you're just going to get not as good compression row oriented. I think the main savings is like flat buffer blows things up by like requiring fixed width types to avoid decoding speed.
I mean, it should be pretty easy to do a comparison in size. Like I have Parquet files where I also have the stats in Thrift in the footer, so that I can compare pretty easily. I think then the comparison that obviously is much more interesting is like an empirical comparison of like, hey, what's the performance of running a query against these things? We actually just merged the other day in Data Fusion an example of like putting arbitrary bytes into a Parquet file as an index. I think the example used like a distinct type index. I'll see if I can rework that to stick like the stats in as, you know, Parquet data and see what it looks like. But I just wanted to check on this call that if that was something people have thought of and if it sounds like absurd or not. And it sounds like it's not that absurd, so it's worth at least trying.
Yeah, in my opinion, it's absurd. I mean, I tend like, but I tend to like think of absurd things also. So I'm not sure I'm the best gauge, but yeah, like I think while we're still in like the initial prototyping phases, we should have different ideas and see how they influence things.
But maintaining separate, what are people's thought on like maintaining a separate file for the min-max values or all these stats for all the files that exist? Like then all the processes of, you know, optimizing the table or clustering the table will need to ensure that the other file also gets updated.
This is the idea is that's not a separate file, right? Like this is separate from table formats where the actual the actual kind of compression that you have is you're embedding the Parquet file. You're embedding like a lot of this information as in a Parquet format, right? So you can map Thrift rows to their equivalent Parquet and then try reading them and then read that back there. So like if you only
got it.
Right, like yeah, like this isn't, yeah, and that's why I say I don't think we want to solve the table format here. It's just what the new footer format looks like. And if it's a bootstrapped Parquet file, you can potentially make that work. I think there might be some engineering challenges with like yeah, like I don't know if you want to map it directly from Thrift to Parquet and like what that does versus like rethinking some columnar structure for some of these things, but that's like more of a low-level implementation detail.
Would the footer have like a single row group? I mean, are there any cases where we need more than one row group for just the metadata, or could we just say that it's always one?
I think that's maybe one simplifying assumption. I haven't thought that deeply. Is there like a follow on there, Jeff, or what are you?
Kind of thinking out loud. I'm just kind of thinking like how much. I mean, are you going to like recursively do this? Probably not. Like,
right.
You still need a footer for your new Parquet file at the end, which you know, if it's only one row group, it's much smaller. But
Right, and those are some of the things I think. There's still the bootstrapping problem of like how you actually make sense of that thing.
I mean, I think you need some, and I'm sorry, I'm not very familiar with the inner format of the current footer and stuff, but I imagine it as like some offsets, a schema, some schema stuff, some metadata, and then the row group stats, right? And so I think the point is you still need the other stuff, the offsets and stuff still needs to be in some format. But my understanding is the part that's expensive to parse and usually large is the stats, not the other parts. I may be wrong about that.
I mean, it's kind of a hierarchical thing, right? So like if you have a row group, the row group has attached to it all the offsets and all the stats for all the columns.
I see.
In that row group.
Yeah. I guess my thought would be just keep the other stuff kind of as is for now, for compatibility reasons and whatnot, and just add the stats as columnar, the same serialization as Parquet itself.
Right. I think that this is a very reasonable point, right? Like we're currently using a big thrift structure that can't be pulled apart and projected. The next, I think, iteration of this was to use a flat buffer system, but like we're still fundamentally like running up against problems of using I think simplistic solutions for something that needs to be probably columnar for stats, and like we need to basically plan what needs to be columnar about the footer, what do we always need to read and understand, and separate those things, and then like reliably serialize them in something hopefully better and more like frankly well defined than thrift.
Yep, that makes a ton of sense. And my thought is, if you're looking for a format where you can project and select individual bits, if only someone invented a efficient one that's widely supported.
Yeah, but there's still a lot of overhead and weirdness to using Parquet pages for these things, right? Like, yes, you can automatically interpret Parquet pages and like that's great. I'm not sure I would use Parquet for this versus like having some. I mean, because frankly, like what Parquet does in a lot of cases is it just stacks up plain encoded values and then uses Z standard or something else to like. Should we? I think that there are a few changes. One is like page level stats. We should probably move out to some section and actually go and compress them. That's a question. We should take row group stats and actually move them out of the footer itself. And then can we have a serialization for the remaining content in the footer that is more reasonable than thrift?
Fair point. What you're suggesting is the meaty chunks, the ones that take the most amount of memory and are needed for each and every chunk, move them out of the main footer. Just maintain like basic column metadata.
Yeah, and we do that for the page stats today, right? I just wish that we, for the page stats, had said, okay, here is a column of page stats, and by the way, we're going to start it off with the lower and upper bound values for the entire column or the entire row group.
Isn't that similar to, and it's been a while since I looked at the Alcas's proposal, but I mean, wasn't part of it breaking out the stats and associate them more with the column chunks and where we write those out so that you can interpret those separately from? No, that wasn't. I may be thinking of.
No, I think what he proposed was, I think, stats being integers and like it wasn't about moving them to a separate chunk.
Oh, okay, so yeah, because like I think that there's, I can't remember, I think there's a different file format that does this, where it's like effectively you do what Ryan is saying, you take like the column stats, but then you append them to the column chunk, and so they're associated with the column chunk, and then in the footer you're just keeping references to where the total length is, the offset is of where you need to read those stats.
Yeah, LansDB does that, I think. LansDB.
Okay, I thought that might be it. I'm pretty sure that's the case.
But that also, it's a great idea, but I think that also goes into some extreme because you need to be able to find the stats at one place to be able to prune out the columns.
Yeah, I was going to say, if you start
do more
splitting up
IO,
the
then you gotta
stats,
jump around.
right? If you start splitting up the stats, then that takes away your ability to just like grab all the stats, prune, and then go read the data. You have to start skipping around.
Yeah, so I think they need to be co-located, like for all the columns at a higher granularity, but they need a better serialization, which probably can be compressed.
Right. And I think, I think part of the point is like potentially making them separable so that like you can still potentially get most of the stats on the first thing, but you aren't blocked on the second IO that you might need to retrieve the full thing.
Yeah.
Yeah, so right now we store the entire contents in the footer, but we're saying like if you're just storing like the offsets to where they are, I mean, I think this is getting back to the question of like, do we need a full up like Parquet equivalent for the footer representation? I feel like that overcomplicates things a lot for what we're actually trying to solve for.
Yeah, no, it very well might be an overcomplication. I think the idea is that like the idea worth exploring is like, can we make these things separable in such a way that, if you still do like an optimistic read of whatever you're going to do on the footer, you get most of the value, but you aren't blocked on like reading the rest of it for parsing, because that will still be, because that's painful, right? And right now everything is still in one big flat buffer thing, so you're kind of blocked on doing 2 IOs until you retrieve the footer. If the footer exceeds your optimistic.
So this may be a little unfair to Alcus because he's not here, but I guess the question is like, have we proven or disproven that like the approach that he was going with the flat buffers actually really has some fundamental issues other than just like the size? Like we know it's not separable. Like
I think the size and separability are like the non-separability was not an issue with what he did. Like flat buffers parses very fast in what he did, even with validation.
Mm-hmm.
And validation is really the parsing speed, because flat buffers doesn't require parsing. It's like,
yeah.
But separation at the IO level is also important in terms of like, it doesn't matter how fast I can parse. If I can parse in 10 milliseconds versus 1 millisecond, it doesn't matter if it took me 50 milliseconds to get it from object storage.
right, and that's the size thing, right? Like, so most Parquet readers are reading some largest chunk at the footer, hoping that fits in there, and then do a second IO to pull it back down. And I think what we're saying is you want to avoid that. You want to be able to not block parsing on that second.
What would you specify what that size is? Like if you read, if you read at least this many bytes, you're guaranteed to be able to parse, enough to read this part of the data, right? Like, it's very generic, but right now you have to read it, at least like 8 bytes to get a size. Like reading less than that is useless.
Right. And most readers are reading like at least 64K.
Right, exactly. But like, would we want to specify like, if you read 64K, you're guaranteed to be able to parse at least this part of the footer?
I'm not, well, it's going to be variable length. I don't know what part you can guarantee that you'd be able
to. Because it's going to depend on how wide the table ends up being. And so if it's wide, you will not have that guarantee.
Well, I wanted to flag, trying to get back to my original point, is that when you have a very wide table, like for example, with like some, string columns where you might have even truncated the stats, but the stats are still large is the point for all these columns. But I may be only filtering on like a Boolean column or something like that, where the stats are minute, but I still have to read the stats, parse, yes, but also download the stats for all of those, like large string columns. And that is, in our experience, the bottleneck.
So you need at a minimum, like some length, some pointer to like the, where are the offsets for the stats, and how many, or for the column metadata, and then how many columns are there, right? Like there's some like minimum amount of like fixed width metadata.
Well,
like we would be sure that we need to, my point is we need to guarantee that we put all of that at the end so that you're guaranteed to get it in the first IO.
Well, not necessarily guaranteed. I mean, the problem is when you choose your 16 or 64 or whatever buffer size, right? You do a tail read with that buffer size, then you start interpreting the footer. If the footer's huge, then like you then have to do another seek to get the full footer. So like, let's make sure that just the footer information fits there, and hopefully the row group stats also were captured in that read. And if not, then you go get, you know, you can do the filtering on what do I need to seek to in order to get the row group stats.
Yeah.
You know, sort of this fallback that gives you more options every step along the way.
Right. Yeah. I think we're agreeing. I'm saying that like all the fixed width metadata needs to go at the end. Anything that's not has nothing to do with the number of columns or number of row groups or anything that's variable. If it's fixed width, it needs to go in the end and be part of the first IO. Like.
Right. And I think so I think we're getting like deep into weeds on design, and like it'd be great if somebody wants to you know, either propose some additions that like work with August's change, or like rethink it from scratch to say like here are the design principles we're working under, and here's like what that design looks like in practice. Like this is not a closed thing, right? Like we haven't gotten close to, I think, really approving it. So we can be open to different design things, right? And it just becomes a matter of complexity, right? Like the nice thing about single chunk is it's still relatively simple to make work and doesn't add a lot of complexity to further parsing, which
I think maybe one note to make here as well is I am very much in favor of this idea. We do basically the same thing as you are proposing with like having embedded Parquet. But one thing that Thrift allows for that is very nice is that's completely backwards. It's very easy to make backwards compatible changes, and having some kind of fixed width data format makes it extremely hard. Like you're going to need to do versioning. You're going to need to do a lot of stuff. Like I'm not even talking about backwards compatibility with Thrift itself, but even when you have done this thing, making more changes and adding stuff on top of it will be a lot harder.
I agree with you there, but I think that the way that we encode this is secondary to what we're trying to move around and encode. Yeah. And so like after we sort of know, hey, here's what we want to dump out of this, what we want to keep where, then we can go back and say, okay, is Thrift still a good choice for this? Is flat buffers a better choice? Do we need to compress these things using general compression? Some of those concerns, and address those. And that's where like the idea to use a Parquet page is actually very reasonable, because if we decide to keep like row group and page level stats in a Parquet page, then that brings in the ability to decompress or compress.
Yeah, I think that's completely reasonable. Adrian, if you are interested, I would like to collaborate on maybe writing some kind of proposal for this.
Sure.
I think this is
sounds good. I don't feel very qualified, but I'm happy to help review. And what I can offer to do is do like a really dumb benchmark in Data Fusion, where we do the really dumb thing of just literally putting the Parquet bytes in there and run, I don't know, click bench on it and see what happens.
Yeah, I think we need to be careful, because I thought, at least in Data Fusion, I thought what was added was the ability to put arbitrary bytes before the footer in the file, right? So like, and what you really want to do for reasonable benchmark is there's a documented way of putting arbitrary bytes at the very tail end of the file as like a hidden field.
Interesting. Makes sense.
And so that's really why you benchmark, because you're going to lose out in general if you need to like still read the footer, parse the footer, and find.
I was going to do something like write the file once with the stats, get the stats, write it again with no stats. But no, that makes sense.
Okay. Okay. Yeah. I think we're way over time, so thank you everybody for sticking around, who stuck around, and
thanks.
Yeah.
Bye.
Thank you, everyone.